At this moment, your phone determines precise location only because GPS satellites must continuously correct time according to the theory of relativity. Without this, after one day, the error would deviate by dozens of kilometers. But what if there doesn't exist a common now for the entire universe? At a mathematically precise level, according to that same physics, just differing in a very small state of motion is enough to divide reality into has happened and hasn't happened in contradictory ways. And no description is wrong. If physics allows this, then the question is no longer how time flows, but does the present truly exist? Or is it only something the brain is forced to create to survive in a reality without anchor points? Humans don't learn time like learning a concept. There's no moment in life when we're pointed at the world and told this is time. Time is absorbed gradually, silently, along with living experience. Similar to how the body learns gravitational pull without anyone explaining. We grow up in an order where everything has before-after, cause-effect. And most importantly, there's a moment always called now. From very early on, the brain has learned to categorize the world into three clear regions. There are things that have happened and only exist in memory. There are things that haven't happened and only exist in the form of prediction or worry. And there's a region in between, where action can occur, where decisions can create consequences, where pain is felt and pleasure is experienced. That region isn't called by any philosophical terminology. It's simply called the present. No one needs to prove the present exists. It's not debated. It's assumed. All activities of life revolve around that assumption. A conversation can only occur if two people believe they're in the same now. A promise only has meaning because it's given in the present and aimed at the future. An apology only has effect because it's uttered after something has happened. If we remove the idea that the present is real, this entire structure loses its foundation. The way humans organize society reflects this very clearly. Law only judges actions that have happened. Economic plans only have value because the future doesn't yet exist and can still be influenced. Education only has meaning because humans believe what they do today will affect tomorrow. There's no field of human life that doesn't default to the present being the anchor point of reality. Even memory is built around this assumption. Memory isn't the past itself existing, but traces of the past accessed from the present. We don't exist in memory. We look back at memory from now. The future is the same. All imagination, all anxiety, all hope is projected from a present standing point. The present is like the center of a circle, while past and future are directions extending from it. Therefore, when humans began describing the world through science, they didn't feel the need to re-examine the question about time. Time appeared in equations as an obviously measurable axis, no different from length or mass. If an event happens at 10 o'clock, then it happens at 10 o'clock, regardless of who's observing. There's no reason to doubt that. If two people disagree, one is wrong, or both measured incorrectly. No one thought that disagreement could originate from the very concept of when. In that context, classical physics formed and developed at an astonishing speed. Isaac Newton didn't just introduce laws of motion, but also reinforced a view of time that fit perfectly with human intuition. Time was viewed as an absolute flow, existing independently of all objects and all processes. It wasn't affected by motion, wasn't stretched, wasn't contracted. It flowed uniformly, the same everywhere. In this view, the universe could be sliced into thin layers according to time, and each such layer represented the entirety of what exists at that moment. If an event lies on that slice, it's happening. If it lies behind, it has happened. If it lies ahead, it hasn't happened. all people, all objects, all reference frames share the same slice. Now isn't a perspective, but a characteristic of the world. This image is simple to the point it becomes invisible. It's like someone asking whether you're standing on the ground or not. The question sounds strange, because the ground is the default condition for all steps. Absolute time and absolute present held similar roles in scientific understanding at that time. They weren't objects of study, but the foundation for studying other things. Classical physics successes further reinforce this belief. Planetary motion was predicted precisely. Comet orbits were calculated decades in advance. Bullets flew. Pendulums oscillated. Mechanical waves propagated. All obeyed equations in which time is a common variable for everyone. There was no experiment showing one person's clock could be valid while contradicting another person's clock in a fundamental way. Even when science touched more complex concepts, like electromagnetic fields, this intuition remained unshaken. Electromagnetic waves propagate at a definite speed, but no one asked that speed is measured against whose time. Time was viewed as common foundation. When saying now, everyone believed they were talking about the same thing. This wasn't just a technical issue. It created a sense of cognitive security. Humans could disagree about many things: what matter is composed of, how gravitational attraction works, whether the world is infinite or not. But there seemed one thing impossible to disagree about: what is happening right now. If two people stand next to each other, they can argue about the meaning of an event, but can't argue about whether it's occurring or not. That certainty spread even to philosophy. Even the most skeptical thinkers usually stopped at the present as a fulcrum. Descartes could doubt the material world, doubt the senses, doubt memory, but he didn't doubt that he was thinking. And that thinking occurred in the present. The present became the point that couldn't be withdrawn without collapsing the entire reasoning structure. Also because of this, for hundreds of years, there was no serious pressure forcing humans to re-examine the concept of now. It wasn't challenged by data. It wasn't challenged by internal contradictions. It harmonized too well with living experience and with contemporary scientific models. If something was wrong, people would fix formulas, improve instruments, or refine hypotheses. No one thought the problem could lie in the very foundation of time. The present, in that context, wasn't just a psychological moment, but part of reality's structure. It was viewed as what divides existence and non-existence, like the boundary between what is and what isn't. An event that hasn't happened doesn't yet exist. An event that has happened no longer exists. Only what's happening is truly there. If comparing the world to a stage, then the present is the light currently on. Scenes already performed sink into darkness. Scenes not yet performed haven't been illuminated. And the important thing is, there's only one single light, shining simultaneously for everyone. There's no such thing as two people looking at two different scenes while both being correct. The entire way humans understand action, responsibility, cause and effect all rely on this assumption. If the present isn't shared, if now isn't objective, then the concept of what are you doing begins to shake. But in the initial picture, there was no sign showing that assumption had problems. It stood firm, not because it was proven, but because it had never been put in a situation requiring proof. And precisely that stable state, the state where the present was viewed as obvious as the ground beneath one's feet, is the starting point of the entire story. Not because it's obviously wrong, but because it was correct for so long. Correct to the point that no one thought it could be questioned. There was no reason to doubt time until physics was forced to answer a very specific question. Almost trivial if looking at the surface. How fast does light travel? This question didn't originate from philosophy, nor did it originate from the need to demolish intuition. It originated from very practical technical problems in the 19th century, when humans began precisely measuring electrical and magnetic phenomena, and realized that the equations describing them seemed to implicitly contain a special speed. The equations of James Clerk Maxwell, published in the 1860 seconds, described how electric fields and magnetic fields vary and propagate in space. When solving these equations, people discovered that they predicted the existence of electromagnetic waves propagating at a definite speed, determined completely by the electrical and magnetic constants of vacuum. When plugging measured values in, that speed matched astonishingly with the speed of light already measured by optical experiments. Light, it turned out, wasn't a separate phenomenon, but a form of electromagnetic wave. This itself hadn't yet caused any crisis. But there was an annoying detail. Maxwell's equations didn't say that speed was measured against what? In classical mechanics, speed always carried relative meaning. A bullet flies at a speed of 500 meters per second relative to the ground. A person running on a train will measure different speed compared to a person standing still at the station. There's no absolute speed, only speed relative to reference frame. But in these equations, electromagnetic wave speed appeared as a fixed number, not dependent on the source or observer. To reconcile this with familiar intuition, 19th century physicists assumed that light propagates in a special medium called ether. Ether was viewed as an invisible substrate substance, filling all of space, standing absolutely still, and playing the role of reference frame for electromagnetic waves. Just as water waves need water to propagate, light waves need ether. When that happens, light's speed is the wave's speed relative to ether, and everything becomes familiar again. Absolute time is still preserved, now is still shared. The problem is, ether wouldn't cooperate. Increasingly sophisticated experiments were designed to detect Earth's motion through ether, especially the Michelson-Morley experiment in 1887. The idea was very simple. If Earth is moving through ether, then light traveling in the direction of Earth's motion will have different speed from light traveling perpendicular to that direction, similar to a swimmer going downstream and across a river. But results showed no difference. Light seemed to always travel at the same speed, regardless of measurement direction or measurement time. This null result wasn't just an experimental failure. It was a refusal. Ether didn't reveal itself, despite being hunted by every conceivable method. Subsequent experiments, more precise, more sophisticated, all gave the same result. There was no sign of any special reference frame that light clings to. No ether wind. No absolute motion detected. For many years, physicists tried to patch things up. They proposed that objects contract in the direction of motion through ether, that clocks run slower. These hypotheses were initially only viewed as mathematical tricks to salvage the idea of absolute time. But the more they patched, the more bizarre the structure became. The effects needed to assume to hide ether increasingly resembled ad hoc adjustments, without deep reasons. By 1995, Albert Einstein chose a completely different approach. Instead of trying to save ether, he eliminated it. He started from two simple assumptions. First, physical laws have the same form in all inertial reference frames. There's no special reference frame. Second, the speed of light in vacuum is the same for all observers, regardless of the motion state of the source or the measurer. The important thing to emphasize is these two assumptions weren't put forward to shock. They were put forward to fit the data. No experiment contradicted them. On the contrary, experiments themselves forced physics to accept them if not wanting to construct increasingly complex and unnatural hypotheses. But when these two assumptions are placed side by side, an unavoidable consequence appears. If light speed is the same for everyone, then the concept of simultaneous can no longer be absolute. Not because philosophy demands it, but because mathematics doesn't allow any other way. To see this, just think about how to measure time. To say that two events happen at the same time in two different places, we need a convention to synchronize clocks at those two places. The most natural way is using light to send a signal from clock A to clock B, then adjust so the signal takes the same time going and returning. But if light speed is the same in all directions and for all people, then this synchronization procedure depends on the motion state of the person performing it. Two people moving relative to each other, even very slowly, won't agree on whether two distant clocks have been synchronized or not. Not because they measured wrong, but because each person uses a different slice of space-time to define at the same time the Lorentz equations, appearing unavoidably from Einstein's two assumptions, describe this disagreement precisely. And that disagreement isn't small in principle. It's only small in everyday life conditions because light speed is too large compared to familiar velocities. Mathematics here doesn't allow negotiation. If trying to keep absolute now, we must sacrifice light's constancy. If keeping light's constancy, now must become relative. There's no third choice. This isn't a philosophical interpretation, but a rigorous mathematical structure, verified by countless subsequent experiments. From particle accelerators to satellite positioning systems, what's annoying doesn't lie in clocks running slow or measuring rulers contracting. Those effects can be accepted as technical oddities. The problem lies deeper. It lies in the fact that two valid observers, making no errors, suffering no hallucinations, not using broken instruments, can disagree about whether two distant events happen at the same time or not. And there's no way in physics to say one person is right while the other is wrong. This disagreement isn't about who sees what, because light needs time to travel. It's about the fact that when all signal delays have been subtracted, when all measurements have been referenced to the same convention, space-time structure still doesn't allow a shared concept of simultaneous, two different descriptions coexist, both valid, both obeying all physical laws. At short distances, this difference is small to the point of negligibility. In a room, it's much smaller than the precision of any measuring device. But when distance increases, that difference increases linearly, at astronomical scale. It's no longer a small correction, but becomes a discrepancy measurable in hours, in days, even in years. This creates a situation unprecedented in science history. Previously, when two descriptions disagreed, one could always trace back to an error equipment, method, assumption. Here, there's no error to trace. The disagreement isn't an accident, but an inevitable consequence of how the world operates if the two initial assumptions are correct. And those two assumptions aren't optional. They can't be removed without collapsing the entire architecture of modern physics. Light's constancy isn't just a number in textbooks. It's the foundation for electromagnetism, for the theory of relativity, for the connection between space and time, and for how energy and mass relate to each other through the famous formula E equals mc squared. At this point, one thing becomes clear, though not yet articulated in words if physics is correct. Then now can no longer be a shared entity for everyone. It begins depending on motion state, not because subjective perception changes, but because the world structure forces it to be so. The problem is no longer whether human intuition is correct or not. The problem is whether that intuition can be kept without contradicting a law that's been verified to the point of being undoubtable. And up to now, there's no path allowing keeping both. When that consequence is pushed to its limit, the problem no longer lies in clocks running fast or slow, nor does it lie in measuring rulers, contracting, or expanding. Those things, though counterintuitive, can still be viewed as technical effects, necessary adjustments when velocity approaches light speed. What's truly touched lies much deeper, at a level that previously had never been doubted the concept of happening. To see this clearly, need to clearly separate something very easily confused. The disagreement here isn't disagreement about observation. Two people looking at the same distant event can see it at different times because light needs time to travel. Everyone accepts that. But in all previous models, people believed there was a correct answer to the question, has that event happened or not? At the present moment, light only makes us know later. But the event itself still has an objective state. The new structure doesn't allow that answer to exist in a shared way. When two people move relative to each other, each person has a valid way to construct the simultaneous slice of the universe. This slice isn't subjective feeling, but a geometric structure determined by equations. And those slices don't coincide. Imagine space-time as a four-dimensional map sheet, where each event is a fixed point. A person standing still relative to Earth draws a horizontal cutting line through that map and calls all points lying on that line now. Another person, moving with different velocity, also draws a horizontal cutting line. Also completely valid. Also obeying all physical laws. These two cutting lines tilt differently. And because they tilt differently, they pass through different sets of events. There's no ruler to say this cutting line is more correct than that one. There's no physical criterion to prioritize one slice. If trying to prioritize, we'll have to abandon the principle that physical laws are the same in all inertial reference frames. And if abandoning that principle, the entire architecture of modern physics collapses accordingly. When this consequence is pushed out of abstract geometry and placed into concrete numbers, it becomes more clearly annoying. At distances of a few meters or a few kilometers, the difference is too small to worry about. But when distance is large enough, that difference swells into discrepancies impossible to ignore. An example has become classic in physics, not because it's strange, but because it directly exposes the problem, the Andromeda paradox. The Andromeda galaxy is about 5 million light-years from Earth. This distance is equivalent to about 4 quasi-meters. If two people on Earth move relative to each other at a velocity of only about 1 meter per second, normal walking speed, then, according to Lorentz transformations, the difference in how they determine happening at Andromeda can be up to several days. What's important here isn't what the exact number of days is. What's important is this difference isn't measurement error, nor is it illusion. It appears directly from equations that have been verified with extremely high precision. Those two people don't need to fly in spaceships, don't need to approach light speed, just very small relative motion and large enough distance is sufficient. This creates an unprecedented situation. One person, by all valid physical standards, can say that a distant event has happened. Another person, also by all valid standards, can say that same event hasn't happened yet. Neither person makes an error. Neither uses wrong assumptions. No measurement is corrupted, and there's no physical answer to arbitrate. The question, what is happening far away, right now, a seemingly harmless question, becomes a question with no objective answer. Not because we lack information, but because the world itself doesn't provide a shared answer. This strikes directly at the long-held intuition that the present is a universal thing. If now depends on motion state, then it's no longer a shared slice of reality. It becomes a concept attached to the observer, not in a psychological sense, but in a physical structure sense. At this point, there's a natural reflex trying to keep the present by saying these differences are just convention, just calculation methods, and that really there's still a true present somewhere. But that reflex quickly hits a dead end. If such a true present exists, it would have to correspond to a special slice of space-time. And if a special slice exists, then a special reference frame exists. But the entire structure of the theory of relativity is built to eliminate precisely that idea. Physics doesn't just say we haven't found a special reference frame. It says that concept has no standing in theory. No measurement can detect it. No experiment can confirm it. Keeping it is only a metaphysical belief, not backed by any data. Here, a subtle collapse occurs. Not the collapse of a law, but the collapse of a way of talking about the world previously. When saying this event has happened, the statement carried an absolute meaning. Now, that same statement only has relative meaning. Has happened for whom, in which reference frame. This doesn't make science lose predictive ability. On the contrary, it makes science more precise. The equations operate perfectly. Experiments confirm every word. But the price to pay is we can no longer talk about the present as something standing outside all perspectives. An event is no longer something that happens then disappears. It becomes a fixed point in space-time, existing at a definite coordinate, calling it past. Present, or future is no longer an intrinsic property of that event, but is the result of how the observer slices space-time to describe the world. This view radically changes the familiar image of time's flow. Instead of a river flowing from past to future, we begin seeing a more static structure, where all moments are there. And what's called now is only the position that a specific consciousness is clinging to. What's important is this change wasn't introduced as a philosophical declaration. It wasn't proposed to explain human experience. It appeared as a side consequence, almost unwanted, of keeping physical laws consistent with data. None of those who first developed the theory of relativity set the goal of eliminating the present. But when all other paths led to contradictions, the only remaining choice was accepting that concept could no longer keep its old position. At this point, one could stay silent about deeper consequences, and only use the theory of relativity as a calculation tool. Many physicists have done so, and still do so. But if stopping there, a silent tension still exists. Because if two contradictory descriptions about what is existing are both correct, then the question, what is existence, can't be dodged forever. And when that question is asked seriously, it forces one to shift from talking about events to talking about the structure of entire reality, not by intuition, but by logic. When the consequence of light speed is followed to the very end, one thing begins revealing itself. Not loudly, but unavoidably. It doesn't appear as a dramatic paradox, nor as a philosophical overthrow. It appears in the form of a very ordinary question, even somewhat naive. Can two events in two different places be said to happen at the same time or not? In everyday life, this question has never caused trouble. If two lightning bolts strike two ends of a field, a person standing in the middle sees the light at the same time. We say they happen simultaneously. If a person standing off-center sees one bolt first, we explain by distance and light travel time. But hidden beneath that explanation, there's always a silent assumption that there's a correct answer behind it. A truly simultaneous existing independently of the observer. Precisely that assumption is what can no longer be kept. To say two events happen at the same time, need a way to synchronize clocks at two different positions. The most natural method, and also the only method not biased, is using light. A signal is sent from A to B, then responds back, and time is divided in half. This method isn't optional. It's the only method compatible with light having finite speed and being the same in all directions. But precisely here, dependence on motion state begins appearing. Two people moving relative to each other won't agree on whether that signal going and returning takes the same time in a symmetric way, not because they measured wrong, but because the space-time they're slicing into simultaneous layers isn't the same. In geometric language, each observer constructs a different simultaneity plane. These planes tilt relative to each other. They're not parallel. And because they're not parallel, they slice space-time in different ways, passing through different sets of events. The consequence of this isn't a small technical detail. It touches directly on the question, a distant event, at the present moment, is in what state? Take a specific event. No need to assume anything strange. A star explosion in a galaxy millions of light years from Earth. According to all modern physical models, that explosion is a definite event, with definite coordinates in space-time. It's not ambiguous. It doesn't depend on who observes. Whether it happens or doesn't happen is a factual matter. But the question, has it happened yet, right now begins losing ground. An observer standing still relative to Earth can construct a simultaneity slice passing through a point on their world line and cutting through space-time at a position lying before the explosion's coordinates. According to that slicing method, the explosion hasn't happened yet. It lies in the future. Another observer, moving relatively very slowly compared to the first person, slow to the point of being imperceptible in life, constructs a different slice. This slice, because it tilts differently, can cut through space-time at a position lying after the explosion's coordinates. According to that slicing method, the explosion has happened. There's no measurement to say this slice is more real than that slice. There's no experiment that can arbitrate. These two people don't disagree from lacking information. They disagree because space-time's structure allows and forces that disagreement to exist. The Andromeda paradox is an extreme but transparent illustration of this situation. The Andromeda galaxy is about 5 million light-years from Earth, equivalent to about 4.970 meters. If two people on Earth move relative to each other at a velocity of about 1 meter per second, normal walking speed, then, according to Lorentz transformations, the difference in how they determine now at Andromeda can be up to several days, not a few nanoseconds, not a small error that can be ignored. Several days. One person, by all valid physical standards, can say that the present at Andromeda includes events happening on Tuesday. The other person, equally valid, can say that the present at Andromeda includes events happening on Friday. Neither person is wrong. And this doesn't depend on whether they can see Andromeda or not. It's not related to light travel time. It's related to simultaneity structure. Here, need to emphasize a point often misunderstood. The problem isn't that we can't know what's happening far away because light takes time to arrive. The problem is even when subtracting all signal delays, even when assuming we have perfect information, the question happening still has no shared answer. Previously, happening was understood as a property of the world. Now, it becomes a property of description. An event doesn't carry the label present or past or future in an absolute way. Those labels only have meaning when attached to a specific observer and specific motion state. This creates a profound tension If two physical descriptions are both correct, but assign different existence states to the same event, then the concept of existing begins shaking, not because we don't know how to define it, but because the old definition no longer applies universally. There's a very natural reflex when facing this situation, trying to say that really there's only one correct present. But we don't know how to determine it. But this reflex isn't supported by any physical structure. There's no hidden reference frame pointed out. There's no special slice prioritized. Keeping an absolute present in this context means adding to theory an entity that can't be detected, can't be verified, and plays no role in predicting phenomena. This isn't a philosophical argument against intuition. It's a direct consequence of keeping physical laws consistent with each other. If we accept that all inertial reference frames are valid, and if we accept that light's speed is the same for everyone, then there's no room for a shared now. At this point, physics doesn't say human intuition is wrong. It only says that intuition is no longer part of the basic description. Now still exists in experience, in language, in life. But it's no longer an objective slice of the universe. A distant event can't be labeled happening without accompanying information about the observer. And when that information is added, that label loses the universality it once had. This is the point where many people stop and feel uncomfortable. Not because physics is hard to understand, but because it doesn't allow keeping something once viewed as obvious. No shocking declaration is made. No one says the present doesn't exist. But no one can say it exists in the old way anymore. This contradiction isn't immediately resolved. It's not patched up. It's left as is. Because there's no place in theory to put a patch without tearing the structure elsewhere. Two descriptions are both correct. Two nows are both valid. And there's no physical arbiter stepping up to judge. And precisely in that gap, where old intuition is no longer protected, but new intuition hasn't been built, the language describing the world begins becoming insufficient. When unable to say an event is happening in an absolute sense, we're forced to find another way to say what it is. Not by feeling, not by experience, but by structure. By this point, what makes everything begin becoming uncomfortable no longer lies in who's right, who's wrong, but lies in the old language no longer being usable. When two physical descriptions are both valid but give two different nows, the problem is no longer cleverly fixing intuition, but recognizing that precisely the way we asked the question from the very beginning was contextually wrong. Physics can't answer the question what is happening right now everywhere, not because it lacks information, but because that question isn't compatible with how reality is described. Here, a very silent but foundational change occurs. Instead of talking about things happening, then disappearing, physics begins talking about events, not in the everyday sense, not a noteworthy occurrence, but in the most minimalist technical sense possible. An event is something happening at a definite position in space and a definite value of time. No need to know whether that event is large or small, magnificent or trivial, a supernova explosion, a muon particle decaying in an accelerator, a GPS signal emitted from a satellite, or a small electrical pulse in the brain when you read this line of text. All are placed on equal footing as points in physical description. This view sounds dry, but it solves a problem that the language of happening can never solve. It doesn't need a universal present to operate. An event doesn't need to be happening to exist in the model. It only needs to have coordinates. Just as a city doesn't need to be being lived in to have a position on a map, the map doesn't care about where you're standing right now. It only records that there are locations. And those locations relate to each other according to a definite structure. Precisely here, the concept of four-dimensional space-time appears not as a lofty philosophical idea, but as a technical requirement. When time no longer plays the role of a shared flow for everyone, it's forced to be treated like space, a dimension in the coordinate system. 3 dimensions of space indicate where. The 4th dimension indicates when. And all 4 coexist in a unified structure. Hermann Minkowski. The first person to write this out clearly in 1908 didn't put forward a metaphysical viewpoint. He only said that if wanting to write Einstein's equations in a consistent way, then space and time can't be separated. A direct consequence of this descriptive method is the birth of the light cone. This isn't an illustration for fun, but how physics classifies cause-effect relationships. With each event, we can draw out a region of other events that can affect it past, and a region of events that it can affect future, bounded by light speed. Inside the light cone, the order before-after is invariant for all valid observers. Outside the light cone, that concept loses physical meaning, not yet known. But there doesn't exist an objective order. What's noteworthy is, in this entire structure, there's no place for a cutting line bearing the label now. There's no plane marked as the universe is present. All ways of slicing space-time into space at a moment all depend on the observer. Just as all ways of projecting a 3-dimensional object onto a plane all depend on viewing angle. The object doesn't change, the projection does. When applying this view to familiar objects, an even deeper change occurs. Previously, we're accustomed to thinking that an object exists through time. It's here now. Then a moment later, it's still it, but in a different state. In space-time, that way of speaking becomes redundant. An object is no longer described by it continuously existing, but by its entire history, what's called a world line. A world line is a curve in space-time, connecting successive events related to the same physical entity. Take a very everyday example, a flight from Hanoi to Ho Chi Minh City. In the old way of thinking, the plane is flying for 2 hours. In space-time, there's no is. There's a set of events: takeoff, reaching cruising altitude, continuously changing coordinates, landing. That entire sequence forms a world line. No event in it disappears when the next event happens. They're simply located at different positions in the structure. When applying this to humans, a feeling of unease begins appearing. A human is no longer an individual existing through time, but a world line stretching from birth to death. Each moment of consciousness is a point on that line. There's no self drifting along the line. There's only the line and the points on it. This isn't a philosophical conclusion about the self, but a direct consequence of changing the descriptive unit in physics. Here, need to be extremely careful describing the world by world lines, and space-time hasn't yet said anything about what exists in a metaphysical sense. It only says that if wanting a model not contradicting relativity of simultaneity, then happening is no longer a fundamental concept. Instead, structure, the geometric relationship between events, is what's placed at the center. There's a small but very noteworthy historical event illustrating this shift. When Einstein died in 1955, many of his colleagues didn't speak about discoveries that happened, but spoke about contributions placed into the structure of modern physics. That word usage wasn't accidental. 20th century physics gradually became accustomed to viewing theories as complete structures, not stories progressing through time. Even in modern technologies, this thinking is silently present. The GPS system, for instance, can't operate if viewing time as a shared flow. Each satellite has its own clock, drifting differently due to relativistic effects. What the system does isn't synchronize the present, but continuously calculate the relationship between signal emission reception events in space-time. The daily operational reality of GPS is proof that the structural model isn't extravagant philosophy, but a technical condition for the modern world to operate. The most important thing about this shift lies in it allows physics to continue speaking precisely without needing to immediately resolve human subjective feeling. Instead of trying to save now by patching up concepts, physics simply places it outside the basic model. The feeling of living in the present isn't denied, but also isn't used as the foundation for describing reality. From this point forward, the question is no longer what is truly happening, but which events exist in the structure, and how do they relate to each other. This is a change like shifting from storytelling to drawing maps. Stories need sequence, need climax, need present. Maps don't. They exist completely, and the viewer can only stand at some point on the map to observe. Precisely this language change paves the way for the problem of ontology to appear unavoidably, because when happening is no longer the criterion, the question, what is real, can't continue being answered by intuition. When the descriptive language has been changed from happening to event structure, an unavoidable question begins revealing itself. It's not a grandiose question, like life's meaning, but a very cold, very dry, and very uncomfortable question: what qualifies as existing in everyday life? We rarely have to answer this seriously. We say something has happened, something is happening, something will happen, and implicitly understand that only what's in the second clause is real in the strongest sense. The past is done. The future doesn't yet exist. This intuition runs so deep we think it's obvious, a foundation needing no proof. But as soon as placing it beside relativity of simultaneity, that obviousness begins cracking. The problem doesn't lie in how humans feel, but lies in physics, forcing us to acknowledge many simultaneously valid descriptions. Two observers, flat space-time, no acceleration, no philosophical tricks, no supplementary assumptions. Each person uses the same theory, the same system of equations, the same correct standard, and each person, in a completely legitimate way, assigns the status has happened to events that the other assigns the status hasn't happened yet. This is the key point in physics. Valid observer isn't a psychological concept. It doesn't depend on belief, culture, or feeling. A valid observer is a reference frame satisfying physical laws. No ranking, no standard observer. If an event is assigned a past time coordinate in observer A's system, then, according to the physical model, it's already part of the structure. There's no symbol in equations allowing us to say, correct for A but not real, and precisely here. Ontological logic begins tightening. Suppose we try keeping the familiar position only the present exists. This sounds harmless, even reasonable. But immediately, we must answer a supplementary question, whose present, if answering absolute present, we've directly contradicted relativity of simultaneity. If answering each observer's present, then we've just done something very dangerous, allowed existence to become relative according to reference frame. In other words, the same event, the same position in space-time, can exist for this person, but not yet exist for another person. Not yet known, but doesn't exist. This is no longer an intuition problem, but a problem of logical consistency. Physics doesn't operate on a reality each person their own way. If two observers are describing the same universe, then what exists can't depend on who's looking. There's a very simple way to see this tension. An event S lies outside your light cone. For you, it's in the future. For another observer moving relatively, S lies in the past. According to presentism, intuition, for you, S doesn't yet exist. for the other person S already exists. But the two people aren't describing two different universes. They're describing the same space-time structure. If existence is an objective property of reality, then it can't both exist and not exist for the same event. At this point, there are three logical paths, and only three. The first path rejects relativity of simultaneity. This means rejecting special relativity, GAPS, particle accelerators, a century of experimental verification. This isn't a serious choice. The second path keeps presentism by assuming there exists a privileged reference frame, a true now that physics doesn't let us detect. This is a real strategy in philosophy. But the price to pay is placing an unobservable metaphysical structure above physics, and accepting that equations describing reality don't fully reflect its nature. Not wrong logically, but very hard to justify scientifically. The third path acknowledges that existence doesn't coincide with happening. An event doesn't need to lie in my present to exist. It only needs to be part of space-time structure. What's noteworthy is the third path isn't put forward as a new belief. It appears as a logical consequence when we refuse the two remaining choices. And precisely here, the concept of block universe begins taking shape, not as a metaphysical doctrine requiring belief, but as a shorthand name for a logical reality. The entire set of events in space-time is considered to exist on equal footing. The name block universe can cause misunderstanding. It makes people think this is an immobile, rigid block, where everything has been predetermined. But in this context, block only means not being sliced by a privileged present. Past, present, future aren't three different degrees of existence, but three regions assigned different labels by different observers in the same structure. There's an important detail often overlooked. Block universe doesn't say everything happens simultaneously. It says all events have definite positions in space-time. Cause-effect order is still preserved within the light cone. There's no paradox like effect before cause. The only thing that disappears is the privilege of the concept now. To see this isn't fanciful speculation. Look at how physics actually works. When physicists solve Einstein's equations for the structure of the universe at large scales, they don't solve from the present onward. They find entire space-time solutions satisfying boundary conditions. Such a solution includes the distant past, present, and even the universe's future, not as prediction, but as a complete mathematical structure. In technical language, the equations don't prioritize any time slice. Even in classical mechanics, if rewritten geometrically, we also see the same thing. A planet's orbit isn't the planet moving through time, but a curve in Newtonian space-time. The storytelling way makes us think the planet is here, then there. But the mathematical model doesn't need is. Block universe, in the strict sense, only says that the mathematical model most compatible with modern physics is a model in which existence is assigned to the entire space-time structure, not to a special slice. It doesn't affirm this model is ultimate truth, but it points out that all other models must explain why they need assumptions beyond physics. The coldest point of this act lies in there's no moment we choose block universe because we like it. It appears because the remaining choices all require sacrificing either physics or the objectivity of existence. And this is why many physicists, though not interested in metaphysics, are still forced to face it. However, getting here still can't breathe relief, because if the entire structure exists, if now is no longer the foundation, then another question immediately jumps out. A question more human, more uncomfortable, and impossible to brush aside with mathematics. So, what is our experience of time block universe can be logically consistent, but it hasn't yet explained why we feel time flowing, why the present has such terrible psychological weight. If stopping here, the model would be like an accurate but soulless map, unable to touch living experience. After ontological logic has been pushed to the point where only the present exists, no longer stands firm. Humans' most natural reflex is resistance. Not resistance by argument, but by experience. We can accept that physics describes the world by space-time, by world lines, by structure without a universal now, but right at that moment, a feeling jumps up almost immediately, but clearly I'm here. Clearly time is flowing. This feeling is strong, to the point that many people think if a model can't explain it, then that model must be wrong. But this is precisely where the confusion lasting thousands of years begins, revealing itself. The problem isn't that feeling doesn't exist. The problem is we've defaulted to it belonging to physics, while never checking where it actually comes from. When observing more carefully, we realize something very strange. The time we experience isn't like time in equations. Experienced time has thickness, has intervals, has rhythm. It's not a point with zero length. You don't perceive a mathematical moment with width equal to zero. What you call now always extends, though very briefly. This has been recognized by psychologists and neuroscientists since the early 20th century, and they gave it a rather modest name, specious present. Seeming present. Specious present isn't a point, but a brief time window, usually measured from 1 to a few seconds, where stimuli are gathered into a single experience. When you hear a melody, you don't hear each separate note like a measuring device. You hear a cluster, a passage with shape. When you read a sentence, you don't become aware of each word as independent points. You hold the entire word cluster in your head simultaneously. The feeling of now is precisely the overlapping region of short-term memory, present processing, and immediate prediction. This has been tested by countless experiments. A famous example is experiments on reverse temporal order. If two stimuli occur very close together, the brain can reverse their order in perception without causing discomfort. The brain doesn't record absolute moments, but constructs a consistent story after things have happened. In other words, the happening experience is a post-processing product, not raw data stream. Modern neuroscience goes further. People have found neuron groups called time cells in the hippocampus and entorhinal cortex region. These neurons don't encode position in space, but encode temporal distance between events. They activate in sequences, creating the feeling of flowing even when there's no external signal changing. The brain, in this sense, is a time-constructing machine, not a time-measuring machine. A very powerful metaphor here is cinema. A film doesn't move on the film reel. The entire film exists already as static frames. Movement only appears when a perceptual system, eyes and brain, scans through those frames in a certain way. No one concludes from the feeling of movement that the film reel itself is flowing. But with time, we make precisely that mistake, equating the experience mechanism with existence structure. Block universe, from this angle, doesn't deny time flowing. It only says time flowing isn't a fundamental property of the physical world, but an emergent property of complex perceptual systems when they're placed along their own world line. Each point on that world line has a nervous system carrying memory of previous points and prediction of following points. Precisely this asymmetry creates the feeling I'm passing through time. The key point lies here. Experience is always local, while physical structure isn't. You're only ever at one point on the world line. You never see the entire line. Therefore, to you, everything always seems to be opening toward the front and closing behind. But that doesn't say anything about whether other points on the line exist or not. There's a very everyday but extremely accurate example. When you stand in a long tunnel, you only see a small segment around your position. Ahead is unseen darkness. Behind is the segment already passed. No one therefore concludes that the road section ahead doesn't yet exist. Limited experience doesn't mean limited existence. But with time, we're accustomed to reasoning that way. Another reflex often appears here. If time flowing is only experience, does that make it less real? The answer is no. Pain is also experience created by the brain, but it's completely real. Color is also experience constructed from neural processing. But no one considers the world black and white just because photons don't carry color. That a phenomenon has biological origin doesn't make it illusory. It only indicates which descriptive layer it belongs to. The fatal confusion in thought history lies in we've tried using experience as foundation for ontology. We say the present exists not because physics forces us to say so, but because experience forces us to feel that way. But once having separated the two layers, physical structure and experience mechanism, we're no longer forced to defend intuition at all costs. Here, need to emphasize something very important to avoid misunderstanding. Block Universe doesn't say your experience is wrong. It says your experience isn't the measure of reality's ultimate structure. Just like the feeling the ground is flat is a valid experience, but isn't an accurate geometric description of Earth. Precisely this clean separation frees both sides. Physics doesn't need to explain why now has special feeling. That's the job of neuroscience and cognitive science. Conversely, human experience isn't threatened by a cold physical model. It's only placed in its proper place in the larger picture. However, a large hole still remains, and it can't be ignored any longer. Even when accepting that the feeling of time flowing is created by the brain, there's still something very hard to swallow. Why does that experience always have direction? Why does memory only point one way? Why do we never remember the future? Why does cause always stand before effect in experience? Though fundamental laws are nearly time symmetric, if block universe is only a static structure block, then what creates the arrow of time so sharp in life and in the universe? This question no longer belongs to individual psychology, but touches straight on the foundation of large-scale physics. When all efforts to place the present into physical structure have failed, and when the feeling of time flowing has been separated from the basic model to be placed in its proper place in the perception mechanism, there's still something extremely stubborn that won't disappear. It doesn't lie in single individual experience, but lies everywhere in the universe times one directionality. No one remembers the future. No glass of water spontaneously gathers molecules to jump onto the table. No star reassembles itself after a supernova explosion. Whatever we call the present, clearly the universe still has an arrow. The problem lies in this arrow doesn't appear where we think. If looking at fundamental physical laws, from classical mechanics to electrodynamics, from quantum mechanics in Schrödinger equation form to the theory of relativity, a very uncomfortable truth appears. They're nearly time symmetric. Flip the time dimension in equations. Solutions remain valid. A film of two elastically colliding balls, if shown backward, has no frame exposing that it's being reversed. At the foundational layer, physics doesn't favor past over future at all. If the present were truly part of physical structure, we'd expect the arrow of time to be carved deep into these very laws. But it's not there. And this is the point making many people confused. The universe has an arrow, but the laws don't. The answer to this paradox doesn't come from finding a secret time flow, but comes from a concept sounding so familiar it's underestimated entropy. But to not go the wrong way, need to say very clearly from the start, entropy doesn't create time. doesn't make time flow and doesn't define the present. Entropy only does one single thing. It creates an asymmetric pattern in a structure originally without direction. Entropy, in the precise physical sense, isn't disorder in the vague everyday way. It's a measure for the number of microscopic configurations corresponding to the same macroscopic state. A state with low entropy is a very special state, very rare in possibility space. A state with high entropy is the opposite, extremely common. What's important doesn't lie in the entropy number itself, but lies in overwhelming probability from a rare state. The system almost certainly will go toward more common states. The key point is, this doesn't need time to flow. It only needs statistical structure. If you place a system in an extremely special state, then when observing different slices of that structure, you'll see low entropy at one end and high at the other end. The arrow appears not because there's flow, but because the structure is asymmetric around that special point in our universe, for a reason that has not yet been fully explained. Began in an extremely low entropy state. This is what is known as the past hypothesis. It is not a law, but a boundary condition, a minimal assumption required to explain why the arrow of time exists. Without it, the entire structure of causal experience, memory, evolution, and life itself collapses. Pay close attention to this crucial point. The past hypothesis does not say that time began to flow at the Big Bang. It only says that the structure of space-time contains a region of unusually low entropy. From that region, when viewed along the world lines of complex systems, entropy increases in one direction. That direction is called the future. The opposite direction, where entropy is lower, is called the past. There is no arrow embedded in space-time itself. The arrow is a global property of a pattern, not a local component of the structure. This is extremely important for the central question of this script, because it shows something decisive. Even the arrow of time does not require a present in order to exist. Memory, for example, is not evidence of temporal flow. Memory consists of low-entropy physical structures, specific configurations of neurons, synapses, and molecules, formed because of entropy gradients. They always point toward lower entropy, because that is the direction in which physical records can be created. If the universe had low entropy in the future instead of the past, you would remember the future and not remember the past. There is nothing in physics that forbids this. It is simply not the universe we inhabit. For the same reason, causes always precede effects in experience. Even though the equations themselves do not distinguish before from after, causes are low entropy configurations capable of generating many higher entropy configurations. Effects are the reverse. This is not a flow. It is the shape of the space of possibilities. When all of this is placed back into the block universe picture, the result becomes very clear. The entirety of space-time exists as a structure. Within that structure, there is a strong entropy gradient, the world lines of systems with memory, cognition, and the capacity to leave records, such as human beings, run along that gradient. At each point on a world line, the system carries information about points on the lower entropy side and no information about points on the higher entropy side. From the inside, this is indistinguishable from time flowing, but nothing is flowing. A particularly precise analogy here is a book with a gradual color gradient. The early pages are very bright, the later pages gradually darken. The entire book exists as a complete object. No page appears or disappears. But if you are forced to read it in sequence, and if your memory retains only the brighter pages, then from within the experience you will perceive a strong sense of direction. That feeling says nothing about whether the book itself was written gradually over time. The key point is this entropy does not restore the present to physics. It does not create a privileged moment. It only explains why. Within a structure that lacks a present, organisms like us cannot escape the sensation of moving from has been to not yet. The arrow of time, therefore, does not rescue presentism. It drives another nail into the idea that the present is the foundation of physical reality. At this point, a new danger emerges. If the block universe, together with entropy, can explain both the arrow of time and lived experience, does it risk becoming a doctrine? Are we quietly replacing an old intuition with a new belief just as strong and just as dangerous? This is a question that cannot be avoided if intellectual honesty is to be preserved, and it forces the script into a highly sensitive territory: serious objections, not emotional reactions. When a model appears to explain too many things at once, from relativity of simultaneity, to space-time structure, to subjective experience and entropy's arrow, skepticism is entirely warranted. The history of science is full of frameworks that once appeared elegant and complete, only for people to forget to ask whether they had exceeded what physics itself truly permits. Because of its logical appeal, the block universe cannot be exempt from this scrutiny. The first serious objection does not come from emotion, but from a very basic concern: is physics being used to answer a question beyond its jurisdiction? Equations describe relationships between quantities. They do not assign existence in a metaphysical sense. When physics says that space-time is a four-dimensional structure, it is describing how events are related, not directly asserting that all events exist in the same way. There is a conceptual leap here, and many philosophers argue that the block universe consists precisely of this leap. According to this line of reasoning, relativity of simultaneity forces us to abandon an absolute present, but not the present altogether. One may accept that there is no universal now for the entire universe, while still holding that at each moment only one slice exists, even if that slice cannot be objectively identified by physics. This forms the basis of more sophisticated versions of presentism and growing block theory. These views typically accept a premise that many physicists find uncomfortable: the existence of a metaphysical structure that physics cannot directly describe. A true present may exist, but remain hidden, unmeasurable, and causally inert. For supporters, this is not a weakness but an acknowledgement of science's limits. For critics, it is too high a price, a reality that cannot be tested, detected, or constrained, yet is assigned foundational status. The second objection focuses on free will. Although the block universe is not identical to determinism, many argue that treating the entire space-time structure as already existing drains choice of its meaning. If every decision you make is already part of the structure, in what sense could you have done otherwise? This is not an emotional question. It touches responsibility, action, and ethics. Defenders of the block universe often respond that could have done otherwise does not require an unrealized future, only that your action is an indispensable causal link. Critics reply that this merely changes the language without addressing the loss of openness. This is a genuine philosophical deadlock, with no clean resolution. The third objection comes from quantum mechanics, not because it rejects space-time, but because it complicates the picture. In many interpretations of quantum mechanics, especially those emphasizing the role of measurement, the future appears to lack definite values until an interaction occurs. This leads some to believe that the future is genuinely not yet fixed, and therefore does not yet exist in a strong sense. Other interpretations, such as many worlds, do the opposite, extending the block universe idea in a far more radical direction. What must be emphasized is this: current physics does not force us to adopt a single quantum interpretation, and therefore does not force us to adopt a single ontology of time. Any claim that quantum mechanics refutes the block universe or quantum mechanics proves the block universe goes beyond what science actually establishes. A deeper and more subtle objection targets methodology itself. The block universe risks conflating descriptive success with ontological truth. A model may be useful, consistent, and predictive without capturing the ultimate nature of reality. The history of science includes many such cases. Four-dimensional spacetime may be an effective perspective, but it need not be the final layer. Crucially, these objections do not undermine the central question. They sharpen it. They force us to admit that the question, does the present physically exist, has no answer stamped as final by physics. Physics can tell us very clearly what is unnecessary, what does not appear in the model, and what leads to contradiction if assumed. But deciding what ultimately exists always lies beyond that boundary. This intellectual restraint is precisely what prevents the script from becoming dogmatic. Throughout this journey, the block universe is not presented as a truth to be believed, but as a powerful, conditional, logical consequence. It holds as long as we demand consistency between physical description and the concept of existence. It becomes controversial only when we try to elevate it to ultimate status. And this marks a crucial shift. If physics cannot decide conclusively, then continuing to argue who is right may be the wrong focus. The question should instead be reframed: how confident does physics actually allow us to be about the things we take to be self-evident? Seen this way, a clear boundary comes into view, not a boundary of human intelligence, but of the scientific method itself. Physics can dismantle intuition, but it cannot replace metaphysics. It can force us to abandon familiar foundations, but it cannot immediately provide new ones to stand on. Beyond this point, attempting to proceed with the same tools, equations, models, physical arguments, would violate the very discipline that made the inquiry possible. Science, no matter how powerful, has a well-defined limit. It describes the structure of the world, not how the world must be experienced. What physics has achieved in this journey is very specific. It has shown that no universal, objective concept of the present appears as a fundamental element in the model of the universe. It has shown that every attempt to preserve the present as foundational either conflicts with relativity of simultaneity or requires untestable metaphysical assumptions. It has also shown that all phenomena typically invoked to justify the present, memory, causality, the arrow of time, can be explained without inserting a privileged now into physical structure. But there is one thing physics does not do, and should not do it, does not declare that the present does not exist. That claim exceeds its authority. No equation measures existence in the metaphysical sense. No experiment distinguishes between existence as structure and existence as experience. Demanding that physics answer such a question is to demand something outside its scope. This is where many people slip. Upon realizing that the present does not appear in physical models, they jump to the extreme conclusion that it must therefore be an illusion. That jump is illegitimate. An experience does not need to be structurally fundamental in order to be real. Pain, color, emotion, meaning none of these appear as basic variables in physical equations. Yet no one concludes that they do not exist. The more accurate statement is this: physics does not grant the present foundational status. It does not use the present to build the world. It does not require it for consistency. And when forced to choose between preserving the present and preserving consistency, physics chooses the latter, not out of ideology, but out of logic. There is a particular humility in this conclusion. It does not say that human intuition is wrong, but that human intuition is not a safe starting point for ultimate description. The present may be central to experience, but it is not central to the universe. That distinction is subtle, but its consequences are profound. Once this is accepted, a different pressure is relieved. There is no longer a need to save the present by inserting it into physics, nor a need to destroy it in defense of a model. Both are defensive reactions, not analysis. Instead, one can adopt a more uncomfortable but more honest stance. Some of the most vivid things we experience are not structural foundations of reality. This inquiry does not provide a new definition of time, nor does it ask you to believe that the present does not exist. It does only one thing. It destabilizes an assumption we usually carry without examination, that the present is so obvious it does not require questioning. After everything considered, one statement can be made with the highest degree of confidence physics allows. There is no evidence that the present is part of the fundamental physical structure of the universe. Everything we call the present, the specialness of this moment, the sensation of temporal flow, the clear division between past, present, and future, can be explained without positing an objective now. This does not make your experience any less real. It only places that experience at the correct level, and when it does, a subtle shift occurs in how we view the world. What feels most certain is no longer identical with what is most fundamental. The present may still exist, but not as a pillar of the universe. Rather, as an inevitable product of a complex cognitive system constrained to live along a world line, carrying memory in one direction and blindness in the other. Perhaps that is the price of consciousness in a universe without a privileged frame. Science does not take your now away from you. It only says that the universe does not revolve around it. And if that realization feels unsettling, it may be a sign that you have reached the edge of an old intuition, where the question is no longer what is time, but why we ever thought we already knew the answer.